This is the fourth lecture video for Sprint 1 Week 2 for educational software design. I just covered how to do the competing software review and how to suggest improvements on the software that you reviewed. In the last section of your deliverable that I'm going to cover now is how to think about writing out a learning problem or a learning goal and how the software might be a solution to it. So I think it's useful to cover Chapter 3 of Interaction Design with this part of the lecture series, because that one talks about thinking about your users and their cognition. So last week I talked a lot about learning science, and in the mind and how people learn, and had to do a lot of that with their sensory input in that processing, their cognition, the thought processes that were built from that. HCI and UX have a lot of overlap there. You have to think about your users psychologically, and part of that is the cognition and decision making that's going on in their mind as they're using your software. And so this is going to be a useful chapter to cover here as we overlap this this last part of your deliverable. This closes out your research diamond. It's kind of a rough draft, the first attempt at your problem statement. I'm sorry, we're not closing out. We're at the midpoint, the widest point. So we're proposing, we're thinking what the learning problem might be, proposing a potential solution just to help state some ideas that might be growing in your head. And this wraps up the midpoint of the research diamond. This opens us up. We've completed the software. This has given you the widest space to look at as we kind of close down the research diamond, which in the next 2 weeks we'll learn about personas, scenarios, and then we kind of state the formal problem statement, which gets a little bit more definition than this. And that closes out with our problem statement. But for now, let's get some training on how you can write your proposed software solution to a learning problem that you're looking to address. And let's jump over to Interaction Design Chapter 3. I'm going to move through it, skim through it briefly, and I'm going to assign you to read the chapter. It's a rather quick chapter, so you'll move through it quickly. It's about looking at your users, thinking about what is their cognition and what type of frameworks can we think about. How do they thinking, and how can you approach thinking about their cognition as a designer? So cognition, we're going to break it down for HCI, for UX, in terms of attention, perception, memory, learning, their output via language, which is reading, speaking, and listening, and their decision areas are problem solving, planning, reasoning, decision making. Just so that you're aware that Norman, that they talk, he's a huge name in UX, so you'll hear his name a lot. And especially when we talk about decision making and actions that users are doing, the information presented them through their interface with the computer and the decisions they make, he had a huge impact on the field on defining all of this theory and frameworks and terminology. So attention is going to be a big part of what goes on in your user's mind, and your own as well. You can only focus on so many things at once. You have to be very specific, have very strong intention of what you present to the user and how it relates to your software. You really want a minimal design, only put up there what really makes sense, or else you can do a lot of information overload. They don't know what to look at, they don't know what to pay attention to, and so really only put up what you need, and it's best to subtract. If you're not sure you need something, just don't add it, see if it works without it, get some feedback, do some user testing, and add to it. So attention, we can look at our goals and our information presented to us in our environment. So we always have something in mind, we're trying to achieve something, our users are always looking. There's no point to a piece of software for a user unless they have some task or some goal. Even something like a game or something like social media where you don't think there's any explicit reason to it. There is. You're socializing. You're looking at what other people are doing. You're reading stuff, news about your world and what have you. So there is actually goals that people are doing, even with software that you think is kind of aimless or just to waste time. And so when you are designing your software and you want to pull the user's attention, I was actually talking about that with the game. I thought that the pause menu pulled the eye in a certain area, even though there was features in other parts of the area. So I think that was poor design in regards to attention. But you have to think about the goals of a person. So when they clicked on the pause menu, for example, they're probably looking for settings or they want to reset the game or something, and you have to give those features direct attention, call outs, and they can go after their goal of setting settings or resetting the game or whatever their option or their goals were. And they are looking ahead a few steps with their attention to solve this goal. And that's why information presentation is very important, because you got to know what your users, who they are and what their goals are, to best present the information in the interface to get them through their series of steps to achieve their goal. Keep their attention focused throughout it with whatever you're presenting them. So, for example, on the left, there's two ways of presenting, structuring information. What makes more sense? What's easier to filter through? How does your attention get held throughout each one? How can you make a decision on what's happening and what you want to do with the information best? So this one's a little bit more clear. I'm missing now. So perception, how the information is acquired in the environment. So think about the colors. How big is the text? Is the text easy to read? The font that you've selected. Different cultures process different colors and even sounds and different environmental effects differently. So thinking about your decisions, are they clear to whoever you're building to, not just for you, but through the perception of the user, and they might think of things differently. They also might have different impairments, so they might be colorblind or might have poor vision or blurry vision. Do you need to make your text larger to accommodate these type of people? Do you need to think about them? So this is some things to think about. So memory is a really important factor. People can only hold so much information in their head on what they're trying to achieve. So think of if you're trying to achieve a goal or a task, and there might be 10, 15, 20 steps to get through it. Are you offering this kind of journey to achieving this goal by the user in a light enough amount of information for each step where they can hold in their memory, their short-term memory, what they're trying to do to achieve a task? Actually, we have divided up into like 3 parts of memory. So there's like long-term, short-term, and working memory. So long-term is remembering big important facts about your life and experiences and what have you. Short-term is maybe over the course of a few days or a week or a month, but you might wake up in the morning and be like, what do I have to work on for the day, or what happened yesterday? That might be short-term memory. And working memory is more what we're concerned with when we think about users and their memory, because there's only so many thoughts or objects that you can hold in your working memory at one time. And I don't know where they talk about it. Here we go. The problem with the magic number 7 plus or minus 2. So you can only hold 7 plus or minus 2. They call it chunks of information. And I wouldn't even say short-term memory. This is actually working memory. So as you're engaged in a task, in a problem that you're trying to solve, you can only hold in your head 7 things, 7 ideas, 7 parts of the problem plus or minus 2. And so a concept or a number or a series of steps you need to follow. So you can think of like following a recipe or an algorithm. You could kind of only hold in your head 7 plus or minus 2 steps. So I would hold an issue with they're saying short-term memory. I would call that working memory. You're engaged in solving a problem. You can only present a user with 7 plus or minus 2 things to solve the immediate problem at hand. And that's memory load. So there's like memory load and then cognitive load. So memory load, how many of these things can you think of quickly? Can you kind of like multitask between remembering to try and solve something? And that's a 7 plus or minus 2 things. And what is a thing? It's like just like an idea in your head, a chunk of information. It's vague, but think of them as steps in an algorithm you're trying to complete. Then you have cognitive load, this idea too, where you can't present too much stuff. It's not even about memory. It's just information overload. You have overwhelming the user. They have no idea what's going on because you're presenting too much visual information or audio information all at once, and their sensory information is blasting through, overloaded into their cognitive side, and it's overwhelming people. So there's this idea of memory load and cognitive load, and you have to try and keep them as low as possible when you're presenting users with tutorials and training, and then presenting them with the educational experience. And for general software, this is true too, because people are coming in, I have a goal in mind, I need to achieve it. There's only so many things I can hold in my head as I'm trying to achieve it. Don't make your user interface and your processes too complicated in your software. So learning. So there's a section on learning. That's great. Whenever you present someone with a piece of software, they have to learn your style, how you're presenting things. They have to learn your terminology, your words you're using. They have to learn your interface. They have to learn your interactions. Like usually it's a single click to do this, a double click to do that, a right click. Maybe there's some hotkeys people are kind of already imbued with, like the arrow keys or the escape key or the enter key. And you try to make use of common conventions like that you think are already trained, that users have already learned. But there's always some type of learning curve to the piece of software, and that's why there's a help menu, there's a help page, there's a tutorial, there's something. Those context-sensitive menus that pop up, tooltips, and what have you. So there is this learning curve with just any type of software, but now you're thinking of a learning curve for a learner. You're actually more focused on the learning curve of the software. You're using it to teach them something. And then we have ideas of language and communication, so language processing, reading text, speaking, and listening. So when you're making your software, we're not using voice commands, so we're more concerned with reading text, and if you wish to use audio too, recording yourself or somebody else and using audio playback for listening. But we'll be focusing mostly on reading text and processing images with user interfaces. Interactive books, just have to skip that. So problem solving, planning, reasoning, and decision making. Okay, so this gets toward the end of the user feedback loop. So sensory information is input into the user. It needs to be processed, refined, filtered, and then users cognate on all this new information coming in. They develop thoughts that are continued from previous ones, or they're having new ones. They're having cognition. And then this leads to behavior, actions, decision making. So thoughts, thinking, cognition is one aspect of psychological processes that are looping in people's heads. And then next is usually they do a behavior, a body movement. They decide to do something. They produce muscle stimulus movements, and they're doing this with a goal in mind, a task or an action that they wish to achieve. So this is the user side turning into output. There's some type of muscle stimulus. They're clicking on something. They made a decision. They're trying to produce an action in their environment. That's their output, which usually gets connected to the computer system input, a mouse, a keyboard, a touch screen, that they're interacting with a user interface to try and change the computer system to solve a goal, which is coming from a decision that they've made, that they've reasoned through from their cognition. And so frameworks, there's a lot of information. We have to try and boil down stuff into simple understandings that we can think about and design stuff within. So we have these ideas of frameworks and models, so mental models. And so I kind of went through the theory of action and information processing. You can read through these. These are just good ways, not only for learning science, but for user experience on how to think about your user and learner. Like, you're the teacher, you're the designer of the software, and you're the teacher of the learning point. Now, how do you wish the learner, the user, you have to think about them. Well, you're going to have a model of them in your head, how they're cognating, how you wish them to cognate the information that you're presenting to them. And I wanted to, the external cognition, I think I had a point on. So theory of action, I was just talking about establishing a goal, forming an intention, specifying a series of actions, an action sequence to achieve what you need to go, and then going through each of those actions, almost like an algorithm, to hopefully at the end of your series of actions, you've achieved your goal. And then how do you evaluate if you've changed the system to achieve that goal? So we have this idea of bridging the gulf of execution and evaluation, saying that the user has these goals, and this is a system they're interacting with, and there's this bridge. They're not connected in reality, but so the user has to have some intentions. They have to specify an action. They have to interact with the interface mechanism. That's the execution bridge over this gulf of a void. We cannot actually interact with this system. Here's a series of steps that we do to try to execute some action on the system. And then the system in return produces some evaluation back to the user to know if they've achieved their goal. So there's this display of the interface. The user must interpret that and then evaluate if their goal has been achieved. If not, do more execution, evaluate, until they think they've achieved their goal through a series of steps of actions. Information processing, how a user process. I've talked a lot about this sensory information. Comes through comparison where they think they're at, eliciting a response and executing on an action. This is interesting. You spend your time looking at the amount of information that we can process at different stages and the speed it takes. But I really wanted to end this on the external cognition, is that people interact with or create information through using a variety of external representations. Oh, right. So this is interesting. So back to the amount of cognitive load that we can hold at one time, the amount of memory load that we can hold at one time. The whole history of technology and tools with humans has helped us to externalize or reduce the amount of memory load, cognitive load, to help us with our computation, our figuring out our reality, to make our best steps or strategies or actions, what have you. So you can think of using paper and pencil to figure out steps in a math equation, or to remember a list of things to do, as externalizing our cognition, externalizing our memory load and our cognitive load to help us achieve stronger thought processes, stronger cognition and memory while using external or physical tools. So abacuses, calculators, paper and pencil, and computers and software all help us to achieve that. So we're achieving a better goal for the user them by themselves and if they use a tool like a piece of software, which is what you're trying to write. I thought that was a neat idea. And again, with computational offloading and the annotation, these are all different ways to offload a mentally taxing work to help us achieve more. So, with all that in mind, you can keep reading. I got basically toward the end of the chapter. You can think about now, hopefully that with that, maybe pause the video or read chapter 3 at your own speed. And I think you're ready now to write this initial proposal. How can a piece of software help somebody learn something? So in this case, we wanted to help students in urban environments, but suburbia and what have you too, but help students in urban environments find it difficult to relate to ecology or wildlife because, they're separated from nature. So we have an issue here. Students in highly industrialized locations or urban locations can't relate to ecology or wildlife conservation lessons because they're so far removed from that topic. So how do we help contextualize, or how do we help educate people who are even more removed from a topic of learning? And so we wish to provide a connection between these urban students and wildlife. And so in this way, we propose to develop an interactive simulation, a way for students who are removed from this knowledge, at least an artificial or virtual way to connect with this knowledge. So they're going to interact with a simulation of an environment and see how their actions impact animal populations and overall health of ecological systems. So human impacts like using rodenticides or rodent poisons or littering or or developing a habitat. How does that impact the animals? So we hope to educate people who are removed from wildlife to like how they're actually impacting or already have in an urban environment. How can we help alleviate those issues in our environment by educating people who are in these urban environments? So that's how we kind of stated the learning problem and how we proposed a solution. We have all these, we're in a highly developed nation. We have a lot of large urban environments. We have an upcoming generation of students, of American citizens that we would like to help educate into how we've already impacted our environment and how they're currently doing it, and something that they might not even recognize because they're in an urban environment. Can we create simulations or fun interactive models of environments and gamify it a little bit to help show them what's happening around them that they might not recognize it? So we stated the learning problem, and then we proposed a solution using software. And so with that, I think you have all of the tools and knowledge necessary to write your own midpoint deliverable with a document purpose, the overview, the proposed solution to a learning problem, and then reviewing some competing software and some suggested improvements on that software.